Students, today we will discuss characteristics of three fundamental particles: electron, proton and neutron. So we will write first of all electron, proton and neutron. Electron, proton and neutron. The major characteristics property we will discuss in this, which are very important to the board examination as well as for the competitive exams. So symbol, you will first of all note symbol. Electron is symbolized as E or E minus, proton P, neutron N. Approximate relative mass, approximate relative mass of electron will be 1 by 1836 time the mass of proton. 1 by 1836, this is 1, and this is mass of neutron is also 1. Approximate relative charge, approximate relative charge -1 for electron, proton +1 and neutron having no charge. It is neutral particle. Mass in kilogram, for the electron it is 9.1 into 10 to the power minus 31 kg. For the proton it is 1.673 into 10 to the power minus 27 kg, and for neutron it is 1.675 into 10 to the power minus 27 kg. Mass in AMU, you will note, mass in AMU, atomic mass unit. Mass in AMU for electron 5.485 into 10 to the power minus 4 AMU. For proton 1.007 AMU. For neutron 1.008 AMU. Actual charge for electron in coulomb, you will note, actual charge in coulomb will be minus 1.602 into 10 to the power minus 19 coulomb. It is plus 1.602 into 10 to the power minus 19 coulomb, and neutron having no charge, 0. In ESU, actual charge in electrostatic unit, minus 4.8 into 10 to the power minus 10 ESU plus 4.8 into 10 to the power minus 10 ESU, and for neutron it is no charge. So I think you are very clear in these all characteristics of these three fundamental particles. Here I will clear you all here. The approximate relative mass of electron is 1 by 1836-37, or sometime we will find 1 by 1838 times of the mass of proton. So actual mass of proton is 1.673 into 10 to the power minus 27 kilogram, and the mass of electron is 9.1 into 10 to the power minus 31 kg. You will divide it, you will find the mass of proton is 1838 times the mass of electron. That means mass of electron is 1 by 1836 or 38 times the mass of proton. And in another aspect we will discuss the ratio of charge to mass for the different fundamental particles. So calculation of, here we will note, calculation of E by m of different particles, E by m of different particles. This is very important for the examination point of view. So first question, anybody ask you, calculate the E by M ratio of, calculate the E by M ratio of different particles. Suppose that question comes that calculate the ratio of E by M value for electron and proton. Calculate the ratio of E by M value for electron and proton. E by M ratio we have to calculate it. E and M. Mass of charge on electron, suppose that charge of electron is -1, we will take it. In proton it is 1. Mass of electron is, suppose that 1, and the mass of electron is 1, mass of proton is 1837 times the mass of electron. E by M value, calculation of E by M 1 by 1, and E by M for proton is 1 by 1837. So E by M value for electron is to proton will be what? 1 is to 1 by 1837. So it will be E by M, the ratio of E by M for electron is to proton will be 1837 is to 1. The right answer would be 1837 is to 1. Now coming towards the another second question. Calculate the ratio of E by M value for proton and alpha particle. So first of all you will write proton, that is the nothing but the H plus ion, and alpha particle, that is the He, dipositive helium ions. Calculation of E by M, E and M. Charge on proton is 1, charge on alpha particle 2, as you know, plus 2. Mass of proton is 1, and mass of 1 mu if we will consider, and the mass of alpha particle 4 mu. So E by M value will be what? 1 is to 1. Here 1 is 2 is to 2 by 4, that is 1 is to 2. So E by M 4 proton is to alpha particle will be what? 1 is to 1 by 2. So E by M for proton is to alpha particle would be what? 2 is to 1. Right answer, right option would be 2 is to 1. Suppose another question comes related to the E by M value. Calculate the, or what will be the order for E by M values for electron, proton and neutron. Suppose electron, proton and neutron, E by M. You will make a table: electron, proton and neutron. Electron, proton and neutron. Charge E and mass of the different particle. Charge of electron, suppose that 1 minus 1, and the mass is E by M. Mass in comparison to the proton, it is the mass of proton, suppose that 1, and the mass of proton is 1837 times, it is the 1, and neutron charge is 0, and the mass is 1838, a little bit greater than the neutron. And one another particle, if given alpha particle, then another include alpha particle. Charge is 2, dipositive helium ion, and the mass is 4 into mass of proton, so 1837 times. So what will be the E by M of the respective particle? 1 by 1. It is 1 is to 1837. It is 0, and it is 1 by 2 into 2 by 4 into 1837, that is 1:2 into 1837. So E by m value will be greatest for electron, then after proton, then after alpha particle, and then for the neutron. This will be the order of E by m value. Another question if comes, that calculate the E by m value for E by m ratio for deuteron plus and alpha particle deuteron plus, and that is the alpha particle He plus plus, electronic charge plus 1, here it is 2, the mass of deuteron is 2, mass of helium is 4, E by m ratio 1:2, here also 2:4, that is 1:2. So the ratio will be E by m ratio for deuteron plus and the alpha particle would be what? 1:1. Suppose another question come, that ratio of E by m value for electron is to positron. Here you will write electron, another antiparticle positron. Electronic charge, here it is 1, magnitude here it is also 1. Mass of electron suppose 1, this mass of positron is 1. E by m value will be 1:1, here also 1:1. So ratio will be what? E by m for electron is to positron will be also 1:1. And another question comes to that the ratio of E by m for helium plus and oxygen dipositive ions. Electronic charge and the mass, helium suppose that 1 plus 1, here it is 2, mass of helium is 4, mass of oxygen is 16. E by m calculation for He plus 1:4, here 2:16, that is also 1:8. The ratio will be what? Ratio of E by m for He plus is to oxygen plus plus 1 by 4 is to 1 by 8, that will be 2:1. The ratio will be 2:1. Okay, thanking you all. I think you have understood these all facts regarding the various E by m values for different particles.